Hi friends, welcome to my channel. In today's class, we will do the isometric view, that is three-dimensional diagram of the given frustum on which we are keeping the hemisphere. Actually, whenever doing the three-dimensional diagram, we need to do the two-dimensional diagram also. Here I didn't do two-dimensional diagram. Here what is the reason means all the data has given, all diameters, okay, and all the heights have given. That's why I didn't do. If any data is missing, initially we had to do the two-dimensional diagram. By seeing it, by measuring it, we can find the unknown data. We can take the data, we can do the three-dimensional diagram. Here all dimensions are given, so no need to do the two-dimensional diagram. It is the main basic reason of not doing the 2D diagram or orthographic diagram. Let us take the given data. A hemisphere of 50 mm diameter. Hemisphere means half of the sphere. Sphere means it is a like round shape object. We have to take half in it. So I am taking this is the hemisphere. Half means it has one side curved surface, one side flat surface. Now here what is the diameter of it? 50 mm. If you are taking the complete diameter, it is 5 cm. Okay. Rest centrally with its flat surface at the top. This flat surface is at the top. We have to keep at one place. We are keeping this over the frustum of a cone. We are keeping this hemisphere on the frustum of a cone. Frustum of a cone means this is the cone. Okay, cone means it has a circular base, and this is the apex. Okay, it is like triangular shape. Frustum of a cone means we have to remove some of the height of this cone. Okay, the remaining part is called frustum of a cone. If you do roughly here, frustum of a cone. So this is the frustum of a cone, because I am removing some of the height here. So after removing here, we are getting circular one, this one. Okay, this is the base. Okay, now we are keeping this hemisphere on the frustum of a cone. Okay, here cone dimensions are cone of base diameter 80 mm. As I told, this is a base which diameter is 80 mm. Okay, and top diameter is 60 mm. This is also circular one. This is 6 centimeters. And height is 50 mm. Height means height of this frustum. Okay, center of this smaller one to center of this bigger one, it is called height. So how much it has given? 5 centimeter or 50 mm. Okay, draw the isometric projection of the arrangement. Isometric diagram we need to draw. Isometric diagram is three-dimensional diagram. So here we are keeping this hemisphere over the frustum of a cone. Okay, we are keeping the hemisphere, just roughly I am doing half of the sphere. The top surface is a circular one. Okay, like this. We are keeping the hemisphere over the frustum of a cone. So here flat surface is at the top. This is the flat surface as I told. Okay, this should be at the top. So this surface should be at the top. This is a three-dimensional diagram. Roughly I did. We need to do this diagram by using all drawing instruments as isometric view. Now here we need to take the orthographic projections initially. So it is not necessary because we know all the dimensions. How much this hemisphere diameter? 50 mm. So what is the diameter of this? 5 centimeter. Let us do this three-dimensional diagram. For doing this diagram, here I want to tell one example. If you are taking this object, any object, okay, whatever this length, we can see the exact length. Okay, if you are keeping like this in three-dimensional way, whatever this edge will be there, it is tilting now in this direction, correct? Whatever tilting object or tilting length will be there in this direction, it is getting reduced. Okay, so at that time we need to calculate the reduced value. Okay, now here this length we can see as it is. In three-dimensional diagram, this length is changing. How much length is changing means whatever this length will be there, we have to multiply with 0.816 mm. Okay, here also we have to calculate all the values. We have to multiply all the values with 0.816 mm. Okay, here let us take this diameter. Okay, 80 mm. We have to multiply with 0.816 mm. Always remember, whatever values will be there, we have to multiply with 0.816. And here 50 into 0.816 mm. By using calculus, we have to calculate this value, 25 mm, this height. It is into 0.816 mm. And here 50 into 0.816 mm. And what about this radius? Okay, here if you are taking this center, this sphere, hemisphere radius, this is the hemisphere radius. if you are taking any round object or if you are taking the sphere in any direction, whatever dimensions will be there, it is looking same, it is looking like ball only. Okay, so for this also, for hemisphere, if you are seeing from any direction, it is looking like same diameter or radius. So here this radius we should not change. Okay, in three dimensional also it is looking like same radius. So sphere radius or hemisphere radius. So h means hemisphere, SR means sphere radius as it is. How much it is? This is the diameter 50 mm, hemisphere radius is 25 mm. Okay, we should not multiply with 0.816. In case of sphere or hemisphere, we have to take radius or diameter as it is. The other values, this value, this value, this value and this value, all will change except this radius of the hemisphere. Okay, let us do this diagram initially. Before doing the isometric view, we will calculate all these values by using the calci. Here take 80 mm diameter, 80 into 0.816. So this value is 65.28. Okay, or we can take 65 mm. So how many centimeters? 6.5 centimeters. Okay. Now here take next value, 50 into 0.816. 40.8. For 40.8 mm we can write 41 mm also. So how many centimeters? 4.1 centimeter. So these values are important for doing the isometric projection. And next value is 25. Okay, 25 into 0.816. So it is 20.4 mm. Or we can write it as 2 centimeter. Okay. Now here again this diameter is 50 mm. Already for 50 into 0.816 we did. It is nothing but 4.1 centimeter. Okay, after calculating all the values, let us do the isometric view. For doing the isometric view, initially take the center of this circle, because cone has circular part. Okay, bottom surface is. So here we need to take the centers. Okay, this center is, let us assume 1. Okay, this top surface center is 2. And this sphere, hemisphere center is 3. Okay, 1, 2, 3. All centers are coming on the axis line. Always remember, because we are keeping this centrally. Okay, on the frustum of a cone. So here, as we know, it is a circular one, but in isometric view it is looking like ellipse. Correct? For doing this ellipse, we need to do the rhombus like this. We have to keep the circular one in this rhombus. Okay, if you are taking like this circle, okay, the bottom circle like this. If you are keeping this circle in a box, okay, let us assume like that. This is the horizontal diameter, this is the vertical diameter. Let us assume how much length it is, diameter of the circle. How much length it is, the diameter of the circle. This is nothing but square. Okay, this box. So what is the diameter of it? We are taking this value. How much it is? 6.5 centimeter. This is 6.5 centimeter. This is 6.5 centimeter. Okay, let us mark the ends here. We can do in isometric view after that. Okay, so this square is coming as rhombus in isometric view. Okay, now just I am marking the names here. A dash, B dash, C dash, D dash, like that. Let us do this box initially in isometric view. Okay, let us take the initial point. I am taking for isometric view capital letters. Okay, after some gap I am taking here, it is capital A. I did one horizontal line of some length. Okay, here we have to take rhombus. So the tilting edges are making 30 degrees to the horizontal line. Okay, for this horizontal line I will take 30 degrees line, 30 degrees line. So here 30 and this side also 30. Okay, here we got 2 points. We need to join these points to A for getting the 30 degrees lines. Just do the line of some length, and this side also do the line of some length. Here we have to mark A, okay, initial point. Whatever initial point is coming, take that point. So in this direction, how much this length? Already I have told, it is nothing but diameter of this bigger circle. How much diameter? For 80 mm we have calculated, it is nothing but 6.5 centimeter. So mark one of the diameter here, okay, it is AB, okay, this length. So it is 6.5 centimeter, and vertically also it is 6.5 centimeter. All four sides has equal length. So take this side is 6.5 centimeter. Mark the end point, make it dark. Okay. Now take this point AB, capital letter B. Now AB I have marked here. This side we can mark AD. Okay. So AD also same 6.5 centimeter. By using compass or scale we can mark the length easily. So this is D. Now we got A, B, D. We need to find C. Okay. Do the DC line. Here we need to do one DC line. This DC line is parallel to AB. Okay, we need to do the DC line parallel to AB. For getting the parallel line, keep this roller scale or drafter scale fixed to this line. Okay, and move the scale up to D. Do the line here of some length. After getting this line, at B also do the line BC line parallel to AD. So here we will get BC line parallel to AD. Move the scale here at B, do the line. The intersection point is C point. Okay, here we got the rhombus for doing this ellipse. Okay, after that, here mark the center of it. What is the center of it? 1. Just join opposite ends with thin lines. We will get the center. What is the center name? 1 I have given here, 1. Here what I will do, instead of initially I will do the rhombus of this ellipse, rhombus of the top surface ellipse, rhombus of this ellipse. So 3 rhombus are coming. First I will do that part in it. After that I will do the ellipse inside the 3 rhombus. Okay. So base rhombus I did here. After that mark this length from this middle point to this middle point. How much it is? 50 mm. Okay, 50 mm we have calculated, it is 40.8 mm. So in centimeter it is 4.1 or 4 centimeter. So it is a vertical height. Just do the axis line from 1. Axis line means 2 big lines with dot. How much it is? 4.1 from 1. Okay. So it is coming here. Do the axis line. Axis line means 2 big lines with a dot. Okay, this point is nothing but center of this top surface. This gap I have marked. So what is the center of it? 2 I am giving. Initially do the axis line for this. Okay. So this is 1 is the center. Do the axis line first. So take this is the reference line. Move the scale up to 1. Do the axis line. 2 big lines with a dot. Okay. Now here this axis line is parallel to this. Do another axis line parallel to this. Two big lines with a dot. Here also extend these lines. So at 2 center, do the axis lines. Okay. Take this is the reference line. Move the scale at 2, do the axis line. Like this. Okay, one axis line. Here also do another axis line parallel to this. Take the scale here, coincide with this. Move the scale at 2, do the axis line. Okay, like this. What is the diameter of the top of the frustum? It is top diameter is 60 mm. We need to find out this value also. It is instead of 60. Let us do here. Okay, calculation 60 mm into how much we need to multiply 0.816 for all values. So into 0.816 mm. Okay, let us do by using calci this value. 60 into 0.816. It is 48.96, or we can write it as 49 mm. So it is 49 mm or 4.9 centimeter. Okay, so here this top surface diameter is 4.9 centimeter. So this diameter is 4.9 centimeter. This is also 4.9. Okay, it is a square. This square we are building here as a rhombus. For doing this rhombus, as I told, each side is 4.9 centimeter or 5 centimeter also we can take. Okay, 5 centimeter. This side 5, this side 5, this side 5. Okay. Now here, as we are taking previously on the axis, we can take half of the diameter. This side half diameter, this side half diameter. So similarly here also I am taking total diameter is 5. Here this side I am taking 2.5, this side 2.5. All four sides 2.5 from the 2. Okay. Mark the value by using the scale or compass. So this side 2.5 and this side 2.5. Okay. And on this side also. So here 1 point, here 1 point. Okay. So at these points do the line. Okay, at this point do the line parallel to this. Take this as a reference line. Okay, move the scale up to this point, do the line. Okay, similarly move the scale up to this point, do the line of some length. Similarly at these points also do the lines parallel to this. Take this is the reference line. Move the scale. Move the scale up to this point. Do the line. Here also at this point do the line. Okay, like this. Now here we got the rhombus. Remove the extra lines so that we can avoid the confusion. So in this rhombus we will get this ellipse of the frustum, top surface of the frustum. Okay. Now here I have marked 1, 2, these two centers. After that I will mark this center. This is 3. Okay. How much this distance? 2 to 3. It is nothing but 25 mm. So for 25 mm we have multiplied with 0.816. How much it is? 2 centimeter. So I will do the vertical line of 2 centimeter. So here it is coming. Just extend the axis line. So this is 3. Okay, 3 is the center. After getting the center of this, okay, 3 here. At 3 also do the axis lines like this. Keep the scale coincide with this axis. Move the scale up to 3. Do the axis line of some length. Axis line means 2 big lines with a dot. So do one more axis line parallel to this. Take this is the reference line. Move the scale up to 3. Do the axis line. 2 big lines with a dot. Okay. At 3 we will get this ellipse. Okay. How much this diameter? Diameter is 50 mm. Okay. So instead of 50, how much we need to take? 4.1 centimeter. So here also we have to do one circle. So each side is, it is nothing but diameter. Okay, roughly I am doing here. So this is diameter of this circle. How much it is? 4.1 centimeter, or we can take 4 centimeter also. 4 centimeter. This is 4. This is 4. Okay. So as I told, from the axis take half in it. Okay. This side 2, this side 2. Total is 4 centimeter. And similarly this side 2 centimeter, this side 2 centimeter. Total is 4 centimeter. Okay. Mark from axis. Okay. From the center take half this side, half this side. Okay. In 4 half means 2. So this side 2 centimeter, this side 2 centimeter. Okay, here 1 point, here 1 point, and this side also. This side 2 centimeter, this side 2 centimeter. Okay, we got 1, 2, 3, 4, 4 points. So at these points we will do the lines. Okay, rhombus lines. So at this point do the line parallel to this. Take this is the reference line. At 3 do the line, okay, of some length. Now at this point also do the line Similarly, at these 2 points also do the lines. Take this is the reference line. Move the scale. Do the line. Move the scale. Here also do the line. Remove the extra lines. So here also top surface we got the rhombus. 3 is the center. For these corners also give the names. Here I am giving capital S, this point, T, U, V. Okay. Now here we got 3 rhombus. This is the first one, second one and third one. Okay, here we will follow the 4 center method for doing the ellipse in all the 3 rhombus. So this rhombus is for getting the ellipse of the top surface, and this second one is rhombus is for getting the ellipse of the top surface of the frustum of a cone, and this rhombus is for getting the ellipse of the bottom surface. Okay, here we will follow the 4 center method. In it I will explain for one rhombus and I will follow the same rule for these 2 rhombus. Okay, yes, so for 4 center method initially we need to mark the middle points of the rhombus. So each side middle point we had marked. This side already we did the middle point here. This is the middle point. For this is a middle point. For this is a middle point. Okay, so in all cases middle points we have marked. Marking the middle points, here in this rhombus, here this is the longer side diagonal. Okay, if you are taking this length, it is more compared to this length. Okay, this is a shorter side, this is the longer side. Always take shorter side 2 ends. What are the 2 ends? CA in this first one. Okay, C one end and the next one end is A, shorter end. Okay, now in this one, which is a shorter one, R and P. Okay, in this second one, R, P. And in this top one, which is the shorter diagonal, U, and here this point is S. Okay, so just I will write U and S. These are the shorter length ends of the 3 rhombus. So after getting this, take initially one of the point in the shorter length. We can take C or A. Join this point
to the opposite middle points. These 2 are the opposite middle point to the C.
Join C to these 2 points by using scale. Just do the thin lines. So I have joined these middle points to one end. So for C, similarly join A to the opposite middle points. These are the opposite middle points to A. Join A and this point, join A and this point by using scale. Here also join. Okay, we have joined, we took 2 shorter ends, we have joined 2 opposite middle points. Okay, mark these intersection points. Okay, some small letters. Let us take, this is X, this is Y. Okay, similarly do in this rhombus also. So this is the shorter length, R and P. Okay, R and P. Okay, join R to middle points, opposite middle points. So these 2 are the opposite middle points to R. So follow the same process for all the 3 rhombus. Now join R to this middle point. Now next end is P. Join this P to opposite middle points. What are the opposite middle points? So this one is 1 point, this one is 1 point. Join these 2 points to P. Okay, we have joined these 2 corners to the middle points, opposite middle points. Here we got the intersection points. I am giving their names. Here XY I have given. Here I am giving X1, Y1. Or you give X2, Y2. For 2 center, okay, I am giving X2, Y2. For 1 center I am giving X1, Y1. Okay. Now similarly in this rhombus also follow the same. Shorter length ends are U and S. Okay. Join U to opposite middle points. What are the opposite middle points? For this side, middle point means this one. Join this point to U and join this point to U. So these are the middle points. So you can ask how to find the middle points, means no need to find, just wherever the axis line is passing through this line, it is a middle point. Okay, here I have joined U to opposite middle points. Next end is S. So join S to these middle points, this one, and where the axis is passing here, this point. Join these 2 points to S. Okay, so here we got the intersection points. Okay, I am giving for the 3 center x3, y3. In all the 3 boxes, we have followed the same process. Okay, we have joined opposite ends to one of the corner. Okay, we are taking intersection points. So here also, here also. After joining all this, so here as I told, here we will get ellipse. For doing ellipse, we are following the 4 center method. In each rhombus, we will get 4 centers. Okay, 4 centers and 4 radius will also come for doing the ellipse. So initially we will take this one. Okay, so first 2 centers are, already I have told, whatever shorter length diagonal will be there, take the 2 corners. Already we took one center is C, the another end is A. These 2 are the centers. Okay, CA. And next centers are these new centers, x1, y1, x1, y1. Okay, in this also, whatever shorter length 2 ends are there, R and P. Okay, the other 2 centers are x2, y2. And next, in it, third rhombus, shorter length 2 ends, U and S. Already we have written. Next centers are x3, y3. In each rhombus, we did 4 centers. Okay, initially take in it. So if center is C, okay, take this radius, this line already we have joined, take this as a radius. Okay, I am giving this length, whatever this length, same length we did here. Okay, because these are the middle points. Take this length, join this point to this point. Take this as a radius. Okay, join this point to this middle point by using the compass. Like this. Okay, after C center, take A center, next center A. Okay, so this C and A are the shorter distance length 2 ends. Okay, initially C is the center, next center is A. A center, take the same length, whatever this length, middle point we have joined. Okay, take the same length, join this point to this point. So similarly, here also, first center is R center. R center, take this radius, join this middle point to this middle point. So initially R center, okay, take this middle point distance. Take this middle point distance, join this middle point to this middle point by using the compass. Now after R, okay, with R we did this. After R we need to take P. Okay, P as center, join opposite middle points. Opposite middle point means from this point to this point. Okay, join these 2 points. Take P as center. This is the opposite middle point. Join this point to this point. Okay, here one arc, here one arc, here one arc, here one arc. Next, take this one, which is the first one, U. U center. Join this middle point to this middle point. Okay, take U as center. Take this is the radius. Join this point to this point. Okay, now after U, take S. S is the center. Join this middle point to this middle point. this rhombus we did 2 arcs, in this rhombus we did 2 arcs, in this rhombus we did 2 arcs. Okay, after that take next center in the first one, x1 center, take this is a radius or this is a radius, both are same, join these 2 points, take x1 center, this is the radius, okay, join this point to this point, this point to this point, middle points. Okay, similarly take next center is y1 center, take this one or this one is a radius, okay, join these 2 points, join these 2, okay, we will get ellipse. Similarly after x1 y1 take x2 y2 centers, okay, in this rhombus, take x2 center, this is a radius, join these 2, next take y2 center, after this take y2 center, take this or this is the radius, join these 2 ends. After x2 y2 take next in this rhombus x3 y3 centers, so take this is the radius, join these 2 ends. Similarly next after getting this y3 center, take this is the radius, join these 2. So we got here one ellipse, here one ellipse, here one ellipse. For this 1 is center, for this 2 is center, for this 3 is center. So here we need to do the horizontal lines, okay, initially for joining slant edges. Just do thin lines. Here also do the thin line. Here also do the thin line. After getting these lines, here take this is the intersection point, okay, take this intersection point. Now here take this intersection point, take this intersection point, join this point to this point for getting the slope line, okay, join this point to this point for getting this line. So keep the scale like this is joining this point to this point, okay. So extend the line but do up to this curved surface, it should not cross this inside the curve, okay, like this. Here also do like that, from this point to this point, keep the scale, do the line up to this curved one, okay. So here we got the frustum of a cone. This is a solid one, we can't see this arc, so it is behind surface, so this part we can see, okay. So make this curve should be dotted, okay, it is invisible. Make it light, this curve. Make it dotted along the line of the ellipse. So this side also. Like this, okay, make it dotted. After that here this part we can see, okay, make it dark, little dark. After getting this frustum of a cone, here we need to do this curved surface. This is the top surface, okay, it is looking like ellipse. Now for doing this, what is the radius of it? Radius of hemisphere, diameter is 50 mm, okay, of hemisphere, half in it 25. As I told previously, for sphere and hemisphere this radius is not changing, because from wherever we are seeing the diameter or radius is constant, okay, in 3D view also. So take the radius 2.5 by using compass. Now 3 is the center, wherever this curve is touching, from it join this point to this point up to this curved surface, okay. Now this is the hemisphere, this is the hemisphere, this is a solid one, we can't see this part of this top surface of the frustum. Make it dotted, initially make it light, after that do the dotted line. So here this is the isometric view of the given arrangement. All outlines should be in dark color. Okay. So invisible part should be with dotted lines. And here mark the given dimensions. The bottom diameter is 80 mm. So instead of new dimensions, mark the given dimensions only. Top surface diameter is 60 mm. Okay, it is 60 here. And then hemisphere, this sphere diameter is 50. So radius is 25 SR I am writing. And this height I am marking 50 mm it has given. And this height is 25. Okay, mark the centers 1, 2, 3. This one center is for this ellipse, 2 center is for this ellipse, 3 is for this ellipse. In this case we did rhombus for each ellipse. So 3 rhombus will come. So this is a method of doing the isometric view if we know all the dimensions correctly. No need to do the orthographic diagram. If you like this lecture, hit the like button, subscribe my channel and share with your friends. Thank you for watching.